Hey guys, in this episode, we're going to make our service more maintainable with infrastructure as code. In the last episode, we used the AWS console to deploy our app easily enough, but doing so can quickly lead to environments getting out of sync or losing track of which resources belong to which apps. Cloudformation helps keep things in order. It can be daunting to build templates from scratch, but the docs are great, your AI assistant can help fill in the blanks, and I'm here to help you get started. So let's get to it. Okay, so the first thing we're going to need is a cloudformation.yaml. And there's basically two sections in here, parameters and resources. So let's start off with resources here. What's the first thing we're going to want to define in our CloudFormation template? Maybe the task definition for our ECS service. So let's go and look up the docs for that. So CloudFormation ECS task definition. And we have a YAML example here with all the things that we'll need. So let's get things set up over here, move all these things out of the way, and we're going to make a task definition. Copy all that, and we'll go through all these properties and only put in the things that we really want to put. So CPU 256, just like last time. We don't need these. The execution role, we will need. Family, don't need that. Memory, 512, just like last time. Network mode, we do actually need that. There's a couple different examples, none, bridge, AWS VPC, and host. Now, for Fargate tasks, AWS VPC is required. So let's do that. Don't need those. We don't have a task role. Okay, so we need the container definition. So let's go over and find the docs for that. Here it is. And this has a whole bunch of stuff. And that didn't get formatted quite right. Move over one. I think that's right now. Okay, so most of these we don't need. Command, CPU. We do want environments. This is where we put in environment variables. We definitely need the image. We do need a name. I believe that's required. Required, yes. Port mappings we will need. Secrets will need that for database credentials. And I don't think we need the rest. Okay, so let's start getting our environments. Let's actually go over to ECS and have a look at our environments we used last time. Okay, so we're going to need the audience. Now that's going to be a parameter because the audience is definitely something that changes between dev, prod, and such. And my rule of thumb is if it's going to be changing between environments, you use it as a parameter. You don't hard code it into your CloudFormation template. So let's get the audience, which is a type of string. We need the database password and user, which all come from a single secret. So instead of bringing in both those individually, what we could do is just bring in the DB credentials secret ARN, which is another string. We need the issuer. So the issuer isn't actually changing between dev and prod, but use your judgment here, but it feels to me like it's something that you should make a parameter anyway. We need the JWKS URI. And the redirect URI, only part of that is actually changing between environments. The only thing that changes is the host name, and we will actually need that host name for something else later. So let's make that the parameter. Okay, now that we have all those, we can set up our environments. So name of the parameter audience. We get the value referencing the audience parameter over here. For issuer, we reference the issuer parameter. For JWKS URI, oops, we reference the JWKS URI. And for redirect URI, oops, this one's going to be a little different. We can use a substitution thing, which lets us basically build a string template. So HTTPS and then hostname, then UI redirect. We also need the DB URL. And that is going to be another substitution. So copy all this, but then replace the host name. Oh, we don't actually have that. We need the DB host. There we go. Other option is to just inject the DB URL, the entire DB URL, but I think putting in the host is a bit nicer because the more application-specific stuff can stay here. Image. So that is the Docker image. That is going to be a parameter. So we reference the image. The name, do we want that? Yes, we want that for the container definition. It's actually required. I usually just put app. Like you could put cats or the actual name of the service, but this is just something that sits inside of our task definition. You can put whatever you want. Port mappings. Let's see how that looks. So that is an array of port mappings. And they take an app protocol, which is HTTP. Is it required? No. If you don't set a value, then TCP is used. Okay, let's use the HTTP. Container port. If you remember last time, that was 8,000, but it's going to be whatever is in your container. Could be 80. Host port, we're actually not going to use that. It's actually not used in AWS VPC mode at all. And the name, we don't need that. The protocol, we don't need that. Okay, secrets, we do need those. If we go back here, we were getting secrets for the DB user and DB pass. So the name DB user is not a value, it is a value from. And here we're going to use another substitution where we take the DB credentials secret ARN, and then just like before, where we add a suffix to get the password and username, this one's going to be username : and looking ahead, I know that this is going to kind of mess up our YAML, so we'll just surround that in quotes. Next is DB pass, and that is very similar. Only difference, instead of the username, it is the password. Okay, we will need an execution role. So execution role, it is a type of AWS IAM role. Now let's look up how we're going to do that. So Cloudformation IAM role. We definitely need an assume role policy document. And I don't really remember how to generate those, but we can see if our AI... Oh, I've already done that. Let's get rid of this chat. That was for my practice run, but we're gonna ask it, can you generate me an assume role policy documents for an ECS task execution role? Yeah, okay. So it's basically given us this, and that looks correct to me. I know you always have to second guess everything the stupid AIs tell you, but from past experience, this looks correct to me. So let's copy that, and we'll be sure to thank our AI overlord, because if it becomes self-aware, we're going to want to be in its good books. The next is the description. Don't need that. In fact, the only thing we want here is the managed policy ARNs. Everything else is optional and not necessary. Looking back at what we had last time over here, let's find the role we used before. Let's search cats, and we had 3 different roles over here for pulling from ECS, for pushing to CloudWatch logs, and for reading and writing from Secrets Manager. All we need is reading, but the managed policy ARNs don't give us anything more specific. Ideally, you would write these yourself, but I'm a little lazy here. That is it. We need to get the ARN. So how do we get the ARN for this thing? In return values, ref gives us the name, get at ARN, that's what we want. So get at execution role.arn. Execution role. Okay, that is it for that. The next thing we'll want is the ECS service. So Cloudformation ECS service. Let's copy all this. We'll call it service. We don't want this. We definitely need that. So cluster, that's the name of the cluster that we'll be using. We definitely want to import that. Cluster name. I don't think we care about any of these. Even desired count, it defaults to 1, but I find if you're using automatic load balancing, putting in the desired count is actually going to override that on every deploy, so I don't like to put that in. Launch type, we definitely want that, because by default it's going to use EC2, but we are using Fargate here. So let's put that in. Load balancers, we'll come back to that. Network configuration, we do actually want that, specifically because we're using Fargate, which requires AWS VPC, which requires some configuration here. So, oops, we copy this, put that in, and look at what we need here. So assign public IP. So ideally, you wouldn't be doing this for an internal service, but we will actually need to be able to access Secrets Manager to get the secrets to push to CloudWatch. And ideally, you would be using some AWS endpoints to get those services available in your private VPC. Otherwise, you have to have what's called a NAT gateway to make it so that your private services can actually access the public internet. But we don't have any of that. We don't have any of these private endpoints. We don't have a NAT gateway. So let's assign a public IP. And this should still be pretty safe because we still have security groups here, which are limiting access to our app here. So even though it technically has a public IP, realistically, you can't actually access it. If you were to be more advanced, this would be an improvement you could do. So security groups ID, security groups, we're going to import that. security group IDs. And this isn't actually going to be a string. This is something that we can actually use a built-in parameter type for. So if we look at CloudFormation parameters, we go over to type. It has all these different types, but we actually want the AWS specific parameter types because this is going to give us a security group ID. Oh, come on. There we go. Okay. The nice thing about using these built-in types here is that it actually gives you a drop-down where you can select it in the GUI. So much nicer, and it also adds some validation. What else do we need for the configuration here? Subnets. It says it's required. No. I think we need it anyway, though. I'm not sure, but we're going to put it in anyway. So that is definitely also something we're going to import. And it's also a built-in type we can use. We want the list. We'll actually call it subnet IDs. Okay. Is that it for this? Yes, it is. Let's go back. Placement constraints, we don't care. A role, we don't actually use one for this, so we don't need one. Service name, the one that generates by default, is fine. Task definition, okay. What does it want here? It wants the ARN. So let's look up CloudFormation task definition. Finds the return values and it gives the ARN. Okay, so we can just do ref task definition, which matches this. Cool. Okay, and we don't need any of those. Now, looking ahead, I actually remember there is something else we may want to add here. It is the requires compatibilities. It's not actually required, but it is nice to put because it ensures that if we want to use Fargate, it will validate whether it is compatible. Otherwise, if we weren't overriding the network mode or giving memory or something, it would happily create this task definition, but not work when we put it in our service. So we're going to put that there just in case. Okay, so what's next? We have our service. Oh, we need to finish off this part here. So let's go back to service, go to load balancers. Okay, this takes an array of load balancers, which take a container name, which isn't required. Container port, we want that, so it is 8000. Load balancer name, that is only if you're using a legacy one. Target group ARN, we do want. Now, we don't have one yet. So that is what we're going to make now. So, CloudFormation target group. Okay, let's copy all this stuff. Now we're gonna put this at the top because it's relatively standalone. Whoa, that's not what I meant. Whoa. Copy all this, paste. All right. Most of these things aren't required at all, on by default. Health check path. So by default, it's just going to go to root, which is fine, but it's a bit more helpful to go to openapi.json because that verifies that the app is actually working properly to a certain extent. but more importantly, it's going to ensure that our app is warmed up. It's much more useful to be able to call something that actually does something substantial like this, generating the Open API spec. So that's going to ensure that when we actually call our app, it's going to be much more warmed up. Useful for a JVM application. So health check, port and protocol and all that stuff we don't actually need. Matcher by default, when we're doing HTTP, it's going to just look for 200 and such. That's fine. Port is, do we need that? Conditional. Okay, so it sounds like we need that. 8000. Protocol, HTTP. Protocol version. We don't need that, I don't think. Targets, we're going to leave it empty for now. Target type, we do need. So if we were using a EC2 cluster, we would use instance, but otherwise it's just IP. That's what we use for Fargate. I wish it told you here, but I know from past experience that is what we need. Don't need that, and VPC ID we do need. So we're going to make that into a parameter. And I closed my list. So CloudFormation parameters. Find types. Go down to AWS specific ones. Search for VPC ID. Really? Why isn't it here? Oh, I need that one. All right. Okay, so the final thing we want to do now that we have our target group is build a listener rule for our load balancer. So let's look that up. CloudFormation listener rule. So this is what's going to attach the target group to the load balancer. Okay, actions. Action type is forward. So we're forwarding traffic from the load balancer to the target group. And the only other thing we want here is target group ARN. So what is the ARN of the target group? Or how do we get it, I mean? So we're on the target group docs, return values, ref returns ARN. Okay, that's easy. For conditions, we're actually going to use hostname mapping for this. So before we made a load balancer that just always forwards to the target group, but I actually want to show you how to do hostname mapping. So let's build ourselves a load balancer. And the benefit of using hostname mapping here is that we can reuse the exact same load balancer for multiple applications, and it's much more cost effective to do it that way. So we're going to call it prod, internet facing, default VPC, and we'll select 3 availability zones, and the default subnets are fine. Security group, we want default and public. So default makes it so that we can talk to our containers. Public means that people can actually talk to the load balancer. And we want a HTTPS listener, except it requires a target group, which is annoying. I wish that it would just let you do anything else. But let's just make a temp one. I really don't care about any of this. And we're not assigning any instances. All right, temp is created. There you go. So later on, we'll customize this. Since we're using HTTPS, we want a certificate. So I've already showed you how to generate one. I'm going to use the wildcard one. That means that pretty much any service can use this load balancer, and it'll be able to serve it with HTTPS. And the rest I don't think we need. Okay, that is going to take some time to create, but right now we can actually go and modify these listener rules. So the default one here, we're actually going to want to edit it. So it is going to be returning a fixed response by default. So what that means is if none of the hosts match in your configuration, you're just going to return a 503 saying, I don't know what you want. And that should be fine. Okay. The other thing we're going to want to do is actually go back to our load balancer. And this isn't required, but it's nice to have. We're going to create an HTTP listener, which is going to redirect to HTTPS. So if you accidentally talk to the load balancer on HTTP, it won't just time out like it would by default. It'll instead automatically upgrade you to HTTPS. So that's pretty nice. And that's all we want. Okay, the next thing we want to do is to set up DNS over here. So we go to our domain, create a record. So wildcard is going to go to an alias. So application load balancer, CA central 1, and that load balancer. So how's our load balancer doing? It is still provisioning, so we're going to leave it alone for now. We can, however, delete the temp target group. It's no longer in use. That is it. Let's go back to our CloudFormation over here. So we need a condition. Conditions. So the field here for the condition is the host header. And we want it to match this host header config values. So we have the option of matching multiple different hosts. We only care about one, and that is the host name property that we imported at the top. So this is going to be cats.andrewohara.com, and it is used by both the redirect URI environment right here, and it is used by our hostname matching. Okay, so let's go back. We need the listener ARN. So that is something we're going to need to import. Listener ARN. And I wish that there was a data type here for ARNs, but for now it's just going to be a string. And I really wish we didn't have to put priorities here. It makes things so annoying when you have lots of rules attached to one load balancer. But you might be tempted to put 1 or whatever. But I actually like to do things in increments of 10. That means that like you can increment by 10, 20, 30, 40. But if you really need to put something in between, you can move it without messing up the others. So we'll start that with 10. And I think that is it. So I found one thing that I forgot to do here. For our task definition, we are going to want to actually want logging. So let's find out how to do that. So let's go back to CloudFormation task definition. Go to the container definition and log configuration. Okay, let's get that in and look at the stuff over here. So log driver, we want AWS logs. We want options. So for options, it tells you all this wonderful stuff over here that you can put, but we can actually take advantage of using what we had before. So if we go to ECS task definitions, and if we look at the latest revision I have over here, it has all these things for us. So let's copy paste all that. Oh, okay, have to do some reformatting. That we were actually going to want to change. You don't really want to be hard coding region stuff into your templates, so we are going to use the built-in AWS region property. So it's going to get you whatever region you're working in right now. Oh yeah, okay. One other thing I forgot here is I'm still not entirely sure if I need the container name, but I don't want to tempt fate, so we're going to put that in. I also forgot to put the target group ARN in, so that is a ref target group. Okay, that should be everything. So let us go over to CloudFormation. Oh, I had this open twice. CloudFormation. And we are going to create a stack here. So let's upload this template. Go to C, code, cats, CloudFormation. And we'll call it cats prod audience. Okay, let's go and get the stuff from our previous task definition. So copy that. Cluster name. That is just prod db credentials secret ARN. So we're going to copy this secret, but get rid of the stuff at the top drilling into the particular parameters of it. db host. That is this. Get rid of this. Host name. That is cats.andrewohara.com. Image. We can't get that from here. We need to get that from ECR. Image 2, copy the URI. Issuer. That is this. JWKS URI is that. Listener ARN. Okay, let's go over to EC2 and go to our load balancer, which should actually be provisioned now. And we're going to copy the port 443 listener ARN. And actually, now that the load balancer is created, let's go to like foo.andrewohara.com and we get our 503 as we expected. We can also go to HTTP and oh no. Why didn't it work? Oh, I think I've discovered my problem. The problem is the security group on this load balancer. So it is using one that only gives you public HTTPS. So let's go over to security groups. Let's actually create a new public security group. So this is going to be public HTTP. Allow public HTTP. And this is going to allow HTTP from anywhere. Okay, let's do that. Then we update our load balancer. Nope, not that. Update security groups, public HTTP. Okay, let's do that and let's try again. Okay, yes, I think that just worked. Yes, all right, okay, much better. Where were we? Security group IDs. We just want default. We don't want public access to our containers. Subnet IDs, the defaults are fine. Ideally, we would use private subnets that we've created, but because we have the security group configured here, blocking access to the public subnets, it's fine. Just use the default ones. And VPC, we'll use our default one. Okay, let's create this. We need to acknowledge that this will create an IAM role. Yep, I knew that. And way too many pages here, so annoying. And okay, this will take a while. Let's, I'll get back to you. Oh, I see I've made a mistake here. Listener rule with extraneous key value is not permitted. Okay. Listener rule value? Oh, I think it's supposed to be values. Okay. We will, so because we made a mistake, we need to actually delete the entire stack because we can't update it. This is really annoying. So I would normally suggest that you make things like piecemeal, like comment everything out except for just one thing, and then slowly add things, because otherwise, if you just put everything in all at once, every single time there's a mistake, you have to delete the stack and then recreate it with all the same parameters again, which is kind of annoying. So I'll get back to you. Okay, I see I've made another mistake. The ECS service is being provisioned. However, tasks are failing here. Essential container and task exited. So best way to debug that is to look at the logs. And the problem here is we are failing to connect to the database. Now, the problem here, if we go to our task definition, we go to the app, and we look at the DB URL, and we see that we actually messed up a placeholder over here. So what we need to do is go over to our task definition over here and add the missing @ and I'll get back to you when that's fixed. Okay, so the stack has finally finished creating. If we go over to ECS and we refresh our tasks, we see that it is running. Now let's go see what else we did here. So if we go to the EC2 load balancer, prod, go to 443, we see that we have a new rule over here with priority 10, which is above the defaults. So if the host header matches cats.andrewohara.com, we will instead go to the target group. Otherwise, we will get the 503 we got last time. So let's have a look at this target group. And we see that we have one target. We can actually go to our task and scale it up for prod. So for prod, I definitely recommend you have at least 2. Oop, wrong thing. Go to the service, update, go to 2 tasks. And the other thing we can do is go down to auto scaling and enable it. So the minimum is 2, the maximum is, I don't know, 200. And we are going to create some scaling policies over here. So it's pretty easy to do this on CPU, memory, or request counts per target. Do whatever you think makes sense for your app. Let's say we're going to do CPU, target of 70 is pretty good. Scaling in 300 makes sense. Scaling out might want to go down to like 60 or something. We'll update that again. Oh, we have to give it a name, CPU. And we can also look at the health metrics over here. And, oh, okay, don't look at the big spike because these metrics are very, very not granular. But over time, you'll get a better picture of how many resources your app is actually using. And you may have a better idea of whether you need to scale on CPU or memory or whatever. And, okay, let's test this out. So we should be able to go to cats.andrewohara.com, and there we go. Pretty cool. So that was your introduction to infrastructure as code with Cloudformation. In the next episode, we'll work on automating your deployments even further with GitHub Actions. But let me know in the comments if there's anything else I've missed. And that's it. See you later.